First, thanks for having me. Just going to jump right in here. For those of you who don't know me, my name is Ryan Stout, and you can find me on Twitter, GitHub, pretty much everywhere on the internet at Ryan Stout. And so I have Twitter at Ryan Stout, but what's interesting is where I'm from, there's a comedian who's really popular who has the Twitter handle at Ryan Stout, or sorry, his name is Ryan Stout, but I have the Twitter handle. And so what's funny is about twice a day I'll get a tweet from some random person on the internet, and I'll look down and they'll say, "You're so funny," and I can't help but think to myself, yes, I am, even though I know they're not for me. And so I just want to give the disclaimer that if I make a joke that's not funny, I've had way too much encouragement from random strangers on the internet. But what I really want to talk about today is complexity in web development. You know, we as developers, I think, especially those of us who have been programming for a long time, I think we start to see this pattern where new technologies come around and we add them into our stack because they allow us to do new things. And this doesn't just apply to technologies, it also applies to techniques, patterns, and things like that. And so as time goes on, we just keep adding those into our stack, and the complexity as a developer goes up and up and up. And I think what happens is eventually we hit a point where the analogy I like to use is it's like packing a suitcase. As you keep adding things in, at some point you're going to just have to dump the suitcase out and start over. And I think we're at a point in web development where the complexity is high enough and we've kind of packed so many things into our technology stacks that I think a lot of people are starting to kind of dump the suitcase out and then look for better ways to do things. And when we're repacking, so to speak, it gives us the ability to actually decide what we need, decide what we can do without, and then occasionally we get lucky and we find a better way to do things by looking at the picture as a whole. And so I think, like I said, we're kind of at a point where we've hit one of these top dots here, and there's a lot of people, I think, myself included, who are now trying to figure out, okay, let's go back and look at the picture as a whole and try to find a way to simplify things, but yet still get all the benefits that we had before. So I want to give a little history, especially for any of you who are newer to web development in particular. I want to give a little history about complexity in web development. I think the last big iteration was around 2004 when Rails came out. They'd had the previous 10 years of building apps that were mostly just rendering HTML and taking form inputs. And so Rails was able to take a lot of the things from the Java web development world and other places and kind of repack them into a better way of doing things. And one of the things that they had that really helped was MVC. And so in 2004, this is basically what your Rails apps looked like. You had routes and models and controllers and views. And all of that was basically just to render HTML. But believe it or not, this was actually much, much simpler and much cleaner than what we had before. And so fast forward to 2005. In 2004, Gmail came out. And Gmail was kind of one of the first, the buzzword back then was Ajax apps, which at the time, for a lot of us, really just meant we were taking our HTML and grabbing parts of it without actually re-rendering the whole page. And so in 2005, Ajax kind of took off, and we started adding that into our stack. And then, you know, as more and more people got into JavaScript development, we started actually just doing some random JavaScript and doing more actual JavaScript instead of just making XHR requests. And then 2007, we kind of keep adding. And then by 2009, we've got so much code on the client side that we needed a way to implement the best practices for getting it to the browser. And so I think Rails was smart. They kind of saw that this was going to be something that was going to be commonplace, and so they added the asset pipeline. So the asset pipeline let us easily implement the best practices for delivering code to the browser. And then fast forward, and in 2011 is when, at least for me, I first started, I think I was using Ember at this time, started doing full MVC on the client side. So not only do I have my models using controllers on the back end, I've also got them on the front end as well now. And then in 2012, we've got so much sort of modular components on the client side that we wanted a good way to bundle all that up and send it. So we added Bower came out at this time, so we started doing front-end asset loading. And then it wasn't really until actually 2013, which wasn't that long ago, that the routers in a lot of these front-end frameworks really got good. And thanks to things like the browser history API, we can now do full front-end routing. So now we've got full front-end routing. So if we look here, this is basically the picture in 2015. We can kind of look longingly back at 2004. But really, I come in day to day, and this is basically the full level of complexity that I have to deal with. And, it kind of bums me out. What's interesting is I think Rails, the Rails team knows this a little bit. I think they're doing their best, but it's funny because I saw this tweet and it says, really looking forward to RailsConf in Atlanta this year. And then he says, Rails 5 is going to be, and then there's this emoticon. And I had to look it up because I was like, I think I know what this means, but I wasn't entirely sure. And it means okay, which at least where I'm from doesn't mean you're really excited about something. Like you say, it's going to be like, how was it? It was okay. That means it wasn't very good. So I don't know. Like I don't know if it was lost in the translation or exactly what happened, or maybe he's just legitimately not that excited about Rails 5. I don't know. I know he races a lot of cars nowadays, so that's probably more exciting than working on Rails at this point. So what's the solution to all this complexity? How do we simplify things? Turbolinks, obviously. No, I'm joking. And my apologies if you're a big Turbolinks fan. Sorry, this is just another aside. So someone asked, will Rails 5 finally be opinionated about which JavaScript framework is the least worst? And DHA says, JavaScript has a great JavaScript framework, Turbolinks. And I think if you guys ever talk to him, someone explain to him what a JavaScript framework is, please. Because I don't think Turbolinks counts, in my opinion. But I mean, maybe it works for him, I don't know. So I think the solution is a phrase that's getting popular now called isomorphic app development. And this means sharing code, it's actually a math term that means similar in form. And if you're trying to get a word popular, you can't go wrong with taking a math word and repurposing it, because in the development community, we typically have no idea what they mean in their math context, but they sound cool, and it's something that's easily available to us. So we're using it in this context to mean sharing code between the client and the server. So if we look at this complexity chart, I think it's pretty easy to see what needs to happen to simplify things. We've got a ton of duplication at this point. So in a perfect world, we'd love to only write one set of views, one set of controllers, one set of models, and then unify our routes. And the nice thing is, once we have models on both sides, there's no need for us to be manually syncing data between the client and the server, because we can just change the model on one side, and then using something like WebSockets or some of the various fallbacks, we can have the model automatically sync to the other side. So I'm going to call this auto-syncing. I'll talk about this a little bit more in a minute. And then ideally, we want to unify our package management as well. So again, isomorphic is sharing code between the client and the server. And I have been working on a web framework called Volt. And if you haven't heard of it, it's an isomorphic web framework for Ruby. And you might be thinking to yourself, how can you have an isomorphic framework for Ruby if JavaScript is the language of the browser? And we actually use a project called Opal. Just show of hands, how many people have heard of Opal? Okay, great, awesome. So I'm going to go into a little bit of detail about it. Hopefully this won't be too much review, but Opal is a Ruby to JavaScript compiler. They actually technically call it a transpiler, and I'll get more into that in a minute. So what Volt gives you through Opal is we're able to share controllers, models, views, and routes between the client and the server. So you can write the same code on the client and the server. And I just want to drive this home because I'm really excited about this. I think this I think this is going to open up a lot of doors for us. Volt gives you reactive bindings to the DOM, similar to what you get in Ember or Angular. You get automatic data syncing that I mentioned earlier. And one of the things that I think is also going to help us drop the complexity down is it's from the gate designed to build apps as nested components. So at least for me as a Rails developer, I'll start out building something and I'll think, okay, at some point I'm going to move this code into a Rails engine or a gem, and when I actually get there to do that, I've realized I've coupled it to all of these other parts of my app. And so the idea behind Volt is if you start out with everything as a component that you can nest together and declare their dependencies, it's really easy at that point to extract it. You literally just copy it into a gem folder because you haven't coupled it from the beginning. Volt kind of makes it more difficult to couple than it is not to couple. At least that's our goal. So let me dive into Opal a little bit, just for those of you who haven't used it. I think there's this complexity, or there's this perception that compiling a language to JavaScript is going to add a lot of complexity. And I think we all kind of come away with a mental image of kind of, there's the complexity of dealing with JavaScript straight up, and then there's the complexity of compiling something to JavaScript. And I think our mental image is that the compiling adds all this complexity, and it's not going to be worth it. And I think if this really was the picture of how things looked, I don't think it would be worth it. I think we need a big win in order for compiling to make sense. And so if we look at just JavaScript, assuming the base with other languages is the same, we've got these problems, right? We've got this is strange, there's type coercion, which causes problems, no standard library, there's the whole category of WTFs, things that just should work but don't. And part of the reason those are there is JavaScript was written in 10 days and then standardized as a language, and the semantics actually haven't changed, partly because they really can't change them. So there's all these problems JavaScript has that makes it difficult to build big apps. And I should give the disclaimer that I've been building JavaScript apps since like literally 1996, and I like it as a language, but I feel like Ruby is a language that spent a lot of years in a small community, and they really worked out all the kinks. And so day to day, I feel like I'm much better able to build large apps in Ruby. And so on the other side, if we look at the perceived complexity of compiling Ruby to JavaScript, you think there's going to be complexity bridging down to JavaScript, there's going to be complexity with the performance, or the performance is going to be high, there's going to be large file sizes, and then there's going to be all this debugging complexity. And I think I can show that actually the picture looks more like this. I will concede that there's a little bit of debugging complexity, but I think you'll see it's actually not as bad as you might expect. This is Douglas Crockford. He's pretty big in the JavaScript community. And he's talking about, he wrote the Good Parts book, if anyone's ever read that. And he's talking about his current JavaScript coding style. And he says, I stopped using new, I stopped using object create, I stopped using this, I stopped using null, and I stopped using falsiness. And part of me wonders, one, what does his code look like at this point? And then two, if a language has so many sort of fundamentally broken parts that you can't use, and these are the tools that it's giving you to actually get stuff done, then maybe we should try to visit alternative ways of working with the browser. So going back to the perception of compiling, this is a quote from someone talking about Opal. They said, every time experimenting with Opal, every time I expected to find an issue, nothing happened. Maybe it'll be time to retire CoffeeScript soon. And so I think what's interesting about this is that it speaks to that perception of we automatically expect it not to work, right? It's kind of one of those, we're used to dealing with the complexities of JavaScript, and so we think, well, if I can't get it right, how is a compiler going to get it right? But the interesting answer is yes. The compiler is going to get it right. So let's talk about transpiling. Transpiling is, instead of compiling to a virtual machine or something like that and then running the virtual machine in JavaScript, which other projects have tried to do, transpiling is actually trying to map concepts from Ruby into JavaScript in this case. So the compiled code actually reads very much like normal JavaScript that you would write, local variables mapped to local variables, instance variables mapped to object properties, methods mapped to functions with the $ prefix, and classes or prototypes with some helpers to get stuff done, like super and things like that. And then talking about debugging real quick, there's kind of a bunch of different things that I think make debugging really great in Opal. Transpiling is the first one. So I'm just going to go through this real quick. So here's some code, and then I just want to look at what the compiled output looks like. So I don't know how much you can see of this, but this is a class body. In the class body, the def object is actually set to the prototype. So you can see here, they're setting some things to nil, and then we have this initialize method that just sets an initialize property to a function on the object, on the prototype object. But when you're actually reading it, this is not too far from Ruby or from something that we'd recognize as Ruby. The only thing that's a little weird is scope.get is the constant lookup in Opal. And then the $- is a method call, the minus method, because in Ruby they're methods. And then here's the rest of it. So I think this is pretty easy to understand, but we can do better than that, because now the browsers have what's called source maps. And what source maps lets us do is take the original code and then load it up in our inspector whenever we're looking through the source files. And then source maps provide a way to map from the lines in the original code to the lines in the compiled code. So now when we get things like stack traces, we can actually see it happened here in the JavaScript and here in the Ruby code. And then you can open it up and edit it. So that's helpful, but we can do better than that. There's also a thing called framework blackboxing, which lets you take parts of your code and say, this is a framework, and I don't want the browser to treat it as normal code. And what that gives you is basically you can sort of treat your framework code, so in this case, that would be the Volt code or the Opal runtime, as almost like native code. So that means it won't show up in your stack traces. It'll just like skip over that because you can kind of assume that Opal code works. So if say you're concatenating two arrays, there's actually some Opal code that will do that. But you don't want to see that in your stack traces. You just want to assume that Opal knows how to concatenate arrays. And so it gives you these nice clean stack traces, or when you're doing a stepping debugger, it'll skip over that. And so it's really great because you end up with clean stack traces that are just your code. Another nice helpful thing is there's Opal-IRB, which lets you run Opal in the browser. And then I think one of the biggest things to help debugging is that Opal is tested against RubySpec. Now they don't pass everything, but they're on their way kind of. And what this gives you though is you basically have a guarantee that for all the things that they're passing, that it's a faithful Ruby implementation. And practically what that lets you do is when I'm writing Volt code, I'll actually do I'll run my tests in both MRI and Opal. And so 95% of the time when I get an error in one Opal or MRI, it will be in the other one. And so that gives me all of the tools available to MRI to actually debug the problem. Another concern is file size. People are worried that it's going to generate these huge file sizes. So we really just care about minified plus deflate sizes. So let me show you this. So this is a bunch of different frameworks, including all the Opal runtime and Volt that gets compiled to the browser out of the box. So these are sort of for empty projects. And as you can see, we sit between Ember and Angular, which I think is pretty good, especially considering we have a full stack sort of data layer that Ember doesn't ship with, and this is not including the Angular router, which we also have a router. So you can see, and I think seeing the transpiled code, you can kind of understand why there's not a lot of overhead here. And then I can also safely say that I've done literally no work so far to try and get this size down. So I think file size is not really a concern. And then the other concern is performance. So these are just a couple of things that I looked at. But for most things, it's pretty close. The one that's interesting actually is the JSON .stringify, which is the JavaScript way to convert things to a string, and then to JSON, which is the Ruby way. And JSON.stringify in the browsers is actually implemented in C. It will actually, in most browsers. So it'll actually go in and run through all of them. And so in Opal, it's actually got to walk through the entire object hierarchy. And so I think considering that the 2JSON does a lot more work, the performance is pretty good, especially compared to the C code in the browsers. JavaScript bridging is pretty simple. So since your local variables are the same and things like that, you can just you can use the backticks in Opal. Instead of calling out to the shell, it calls out to JavaScript. So that's pretty easy in my opinion. And it's nice because anytime you need you can just drop down to JavaScript. So I think hopefully, talking about Opal, I think hopefully you've seen that this is not actually the picture of complexity, that you've actually got, you actually get a pretty big win by using Opal, especially as Ruby developers. You know, we kind of get to take a lot of the best practices with us. So let me talk a little bit about Volt real quick. So Volt gives you a bunch of collections, and collections are basically places to persist data, sort of like what you'd use Active Record for, but the idea is that they all have the same interface, but where the data gets persisted is actually different. So you have page, which is a temporary collection on the page. You have store, which is kind of syncs to your database. Params is the URL parameters, and local store is the local storage, and so on. Volt is not a traditional MVC framework. We're actually more of what's called an MVVM framework. So if you look at an MVC framework, you know, the request comes in the controller goes to the model, fetches some data, the model brings that back to the controller, and then passes it to the view. And in Volt, it's actually different. We actually start with the view, and then the view has a controller. And so each time you hit a binding in the Volt templates, it's going to go to the controller and say, hey, it's going to run whatever code is in the bindings in the context of the controller. So it's going to try and get something. And then if the controller doesn't have that, it's going to proxy it down to the model, and it's going to return all the way up. And so the reason why things are a little different is Rails' style of MVC is really designed to produce HTML, whereas Volt's is designed, the life cycle of these objects is basically as long as that part of the page is visible. And so it makes more sense to kind of do things this way. So I'm going to do, real quick, I'm going to do the dreaded live code demo, and hopefully everything will work for me, but let's see. So for those of you who saw my RubyConf talk, this will be a lot of the same, but hopefully hopefully you'll be able to follow through. So I've already got a Volt app that I'm just going to start up here. Let's see. And so out of the box, what we get is basically a blank app that's got a couple of things. So I'm going to go ahead and go into my code here. And if you look, we've got this app folder. And so this may look familiar to Rails developers, but inside of it, we've got main. And main is our first component. And so, like I said, within app, you're going to have all these different components, but we're just going to start with this one. So one of the things you get out of the box is I can go ahead and change my templates. And as soon as I hit save, it's going to reload over here for me automatically. And we're going to build just a real quick, simple to-dos app, to-do list. And so my bindings, again, are Ruby code. And just to give you a little context, I'm not going to go through all of the details of this, but I kind of just want to show you what's possible in Volt. So here we're going to bind label on our to-do, and then we're going to go ahead and add a form to actually add the to-do. And so this e-submit event says whenever there's a submit, call the add to-do method on the controller. And so if I do an input with to-do, I can bind that to the page collection, new to-do, and then label. And then if I go into my controller, I'm going to say for my controller that I want the model, and again, I'm not going to go through too many details on this, but I want the model to be page for now. And then I'm going to create this add to-do method, and I'm going to just, every time that form submits, I'm going to append new to-do to the to-dos collection, and then I'm going to clear out new to-do. So now, if we go over here, we've basically got, we can quickly add, let me make this larger. We can quickly add to-dos, and all of this code is running on the front end and adding the to-dos to the page. So let's go ahead and make where we can close this. So we'll add, or delete, I guess. We'll add a X button. We'll say when the button gets clicked, let's delete the to-do from to-dos. And then we can delete them. And then one of the other things we might want to do is show how many to-dos we have. So we're going to go ahead and just up here say, show the size. There's 2 to-dos. And then it's obviously not a to-do list without a checkbox. So let's just say we'll make a checkbox. And then we'll bind its checked property to to-do.completed. And then what we want to do is whenever it is completed, since we've bound the complete state of the checkbox to the model, we can go ahead and add a class that says if it is completed, we can show some class. So let's show the complete class if it's completed. And then I'm going to go ahead and just grab some JavaScript, or some CSS from another project. And then in Volt, your assets are automatically loaded by default unless you specify otherwise. So I went ahead and copied that in. And now you can see that as we click, we actually, we don't have to write any event handling code because we've bound things together. And so now as I click, it's going to go ahead and check these off. And the nice thing is, because it's updating the model, we can do some neat stuff like we can say, show me the number of completed. And so I'm just making a method here called, or calling a method called completed on the controller. And then if I go here, make a method called completed, I can just take the to-dos and count them and only count the ones that are completed. And now this is basically automatically updated as we go. So this is not super new, right? You might get some of these, a lot of these features from something like Ember or Angular. But where I think it gets interesting is when you tie into the back end. So here we're using the page collection, which is this temporary in-memory storage. I can actually change this to store, and store automatically syncs with the database. So you notice when it reloaded, we got a different list of items. And then if I open up another browser window and I change the state of the app, so this would be for anyone anywhere around the world connected to the app, it's going to just go ahead and sync all of my changes. And because of the reactive DOM, it's actually updating everything without me writing any code to do that. So I think this is pretty neat. Like, I think this is, not that everyone needs real-time maps, but I think kind of real-time by default is a nice feature to have. Let's see. So one other thing real quick. So another thing that we might want to do is have it where when we click on one of the to-dos, we can get a select, we can see which one's selected. So on my TR here, I'm just going to add a click event that says use the params collection and set the index on the parameters to the current index. So I'll do an each with index, pass the index. And now, now what we get is when we click on one of these, I don't know if you can see this, but it sets index to the index for the item. And then what we can do is in our controller, we can say, grab our current index, back from params, convert it to an integer because params come in as a string. And then we can make a current to-do method that just looks up the current index within the to-dos. And we can use that from our view to say if there is a current to-do, so if it doesn't return nil or something, then we can say show the label, and then we could bind some other property to it. And so now what I get is whenever I click on one of these, you can see down here that it's actually showing me the data for it. Let me go ahead and make a selected class just so it shows which one's selected. Okay, so now whenever we click on one of these, it'll highlight the selected one, and then we get this where we get this text area that gives us some notes or something, and again, it syncs to all the listening clients. So one last thing we might want to do, I just want to show using Vault components real quick. So here we have this problem where if we hit enter, we can enter empty to-dos. And so let's say we want to add some validations to that. So what we can do in that case is go ahead and bring in a component gem. So there's this Vault fields gem. I'm going to go ahead and install that real quick. And what Vault fields gives us is basically field helpers for things like validations. And we'll declare our dependencies, and then if we go in here, we can actually change our input to use the tag, special tag that fields provides. So we'll say it's a text field, for example. And then we can go into our command line, generate a model called to do. And then in our model, which will get loaded up kind of by convention, we can say validate, label, make sure the length is 5. Okay. And then now what we get is, hang on. This is why live coding is always a bad idea. Oh, sorry. Okay, there's actually one other thing I have to do. So I actually have to make a new method that sets up the to-do. And I'm going to set that to what's called a buffer on store. So buffer is sort of like a normal model, but it's not synced automatically until we call save on it. And then so what we'll do is when we do call save on it, we'll go ahead and after it saves, we'll call new again. Okay, so now, really quickly, we've got this live validating field that will only let us add items once it's validated. Okay, so that was a real quick demo of Vault. Hopefully that kind of gave you a sense of some of the things that you can do with it. Again, I mentioned components that can provide these tags that you can reuse, and it's really easy to repackage them as gems. We have some components already. So we have field error messages, pagination, file upload, Google Maps, login, sign up, authentication, things like that. Also want to mention tasks. Tasks are an easy way to kind of call server code from the client that you either don't want to load everything up because of security or something like that. And then real quick, this is not quite out yet, but permissions is almost done. So I showed the validations. Our permissions are basically model level where you can say you want to deny or allow different fields to be either it's basically the CRUD operation. So created, read, updated, or deleted. And you can actually be granular and say, I only want the owner to be able to change it once they make it, or an admin or something like that. And then you can be specific. You can say, okay, anyone can read all the fields except for notes, for example, which only the publisher could read or something. So just real quick recap. So some of the things that Vault gives you are the auto-syncing. Because of the auto-syncing, you're not building all these REST APIs, which I think, at least for me as a developer, I spent a ton of time in the last few years writing REST APIs just for the purpose of syncing to my client. And so being able to kind of automatically have the framework handle all that is great. You can write in one language, so there's not the complexity of switching between languages. Components simplify things. Having a single framework for the client and the server simplifies things. And then I think one of the big benefits is centralized state. So you're holding all of your state in these various models, and so you always kind of have an authority for where the state is. And so you don't have to actually go and kind of wonder, okay, I've got some state in my DOM, some state in my model, some state in my controller. All of that's automatically synced. And then I didn't show it, but we also have a unified router for the front end and the server.